All right, so again, it's just the idea of they give me all these medians, right, to tell me that X is the centroid. But when I look at question 16, they're only interested in looking at G to K, right? G to K and X. Okay, so I'm going to redraw my picture so that it just focuses on that segment. Okay, so we've got G there, X there, K there, right? The procedure then says, if based off the parts that they give me, and this is the one thing that a lot of people are struggling throughout the day. I had a lot of people help me or ask for help from me in Wildcat time today, is that we're able to recognize which portion is the 2/3 portion. Okay, would you all agree that this here is the 2/3 portion? Okay, so the red is 2/3, and when we phrase it, it's 2/3 of the median, right? Of means what in mathematics? Times. So it's 2/3 times the median. So in any type of equation that we set up, the 2/3 always needs to be on the median side. Does that make sense? It needs to be multiplied by the entire median. So when I'm looking at this expression here, and they want to know what X to K is, now I should have gone a little bit further. X to K is what portion of the median? 1/3 of the median, right? So I first got to decide which ratio to use. So they're saying X to K, so I know I got to use the 1/3, right? So X to K, the way I write this is that X to K is 1/3 the median. Okay? So I'm going to plug in the values that I know. Then X to K, 1/3. My median is 13.5. Okay? Now, I don't want to grab a calculator because this is actually a little bit easier to do without a calculator. 13.5 is better written as what fraction? 26 over 2 would be what? 13, right? So 27 over 2 would look like that, wouldn't it? Okay. So do we agree then that that 3 and that 27 will cancel? And I get 9 over 2. Okay, so most of you probably grabbed your calculator, typed 1/3 times 13.5, and got 4.5 back, right? We get 9 over 2 same way. Okay, it's the same value, 4.5. But the reason I like that is because 9/2, and then obviously calling that 27/2. Sorry, the whole thing would have been 27/2. When I compare 9/2 to 27/2, if I divide those, multiply by the reciprocal, I get 2 over 27 right there, right? What happens to my 2's? Cancel, right? How many times does 9 go into 27? 3. So I'm left with 1 up top and 3 on the bottom. So I replicate that 1/3 that I knew I should have started with to begin with, which is a nice kind of built-in check. If I'm using fractions, that's not too bad. Obviously, if you're using decimals, you can do the same thing. You can take a calculator and type in 4.5 divided by 13.5, and it will work out to be 0.3 repeating. My only issue is that when it's not a really nice terminating decimal, and you got to round it, and then you use that rounded value to plug that in and check to see if you get 1/3 or 2/3 back. You might get like 0.66984 back or something like that. Okay, which you have to make the connection that I rounded. So when I plug in, I'm not going to get exactly 2/3. I'm going to get something really close to it. Okay. Same idea on 17 and 18 then. 17, if fx. Okay, so we're looking at that portion right there, and it's being compared to xj, right? Those are the things that they're providing me, and they're asking me about how does the blue segment relate to the red segment. Yeah, the blue one is twice the red one, right? So if they're saying the blue one is 10.6, the red one has to be what of that? The blue one's twice as big. That means the red one is half the size, right? So if 10.6 is the blue one, then the red one's got to be 5.3. Okay. If we're looking at 18, h to x, that distance there, and then they give me the overall h to I. Okay, so would we say hx is equal to 2/3 of hi? Well, that means if I'm trying to find hx, it's 2/3 of 9. Those cancel, leaving me 3. 2 times 3 is 6. So hi being 9 provides hx to be 6. And then if I compare, 6 compared to 9 gives me 2/3, doesn't it? Okay. If that whole thing, that whole blue one is 9, this one's 6, this one here is 3. What's 3 compared to 6? There's my half. What's 3 compared to 9? 1/3. Okay. So that's kind of how you would approach those. My thought is, and this is why I gave you these were probably a little bit easier than maybe these, weren't they? But if you're able to continually get, just using concrete numerical values, and apply the 2/3 on the right side, apply the 1/3 on the correct side, then when you get down to these equations, hopefully you've developed a process that allows you to set them up correctly. When we do something like 19, okay, I think 19 is probably a good one to talk about. If I've got E, Q, and V, okay, EQ and EV are the things that we're trying to relate to one another, right? So EQ and EV, okay? Would you guys agree that EQ is what ratio of the whole median? It's going to be the what part? 2/3. That's the 2/3 part. Q to V is the 1/3 part then, right? Okay. So E to Q is what they give me. So the way I write this, if we say EQ is 2/3 the entire median. Okay. Everybody I've worked with today has said, I even checked my answers. Okay. I worked through this and I found that maybe x was 52 or something, and I plugged that back in, and I plugged it back into my original equation, and it worked. They said the left-hand side was equal to the right-hand side. When you do that, understand when you plug back into the equation that you started with, all that does is tells you the algebra that you've done is correct. It does not tell you that the geometry you used to set the equation was correct. Okay? So if you're a person that put 2/3 on the other side, went through math, and got all that math right, that's great. That's awesome. Okay? We got to focus on the geometry. We got to make sure we got 2/3 on the right side. And I keep saying the right side, but the correct side. Okay. Now it's a matter of taking and writing this as x plus 4/5 equals 2/3, and now we have 8/5 x plus 1/10. Okay. Now what do people hate about this equation? It's got fractions, right? Okay. With this particular problem, I think the best thing to do, you can, but it gets people in trouble, trying to get rid of fractions instantly, right away. It's probably not until the second step that you really want to do that. Like I said, you got some options here. What I would do is probably just distribute here. I think that's probably what most people would feel comfortable with. It's the least likely to allow you to make errors. So if I take 2/3 times 8/5, what's 2 times 8? 16. What's 3 times 5? 15. So that gives me 16/15 times x. And now I'll take 2/3 times 1/10. What's 2 times 1? 2. What's 3 times 10? 30. And now over here, it's just x plus 4/5. I didn't have to do anything over there. Okay? That makes it a little bit easier, I think, to know how to get rid of fractions or where, what value to use, I guess, to get rid of fractions. What could you multiply everything by here to get rid of all fractions? If I multiply by a common denominator of 30, will that get rid of all fractions? Okay. So I see 30 here. We'll multiply this by 30. I'll multiply this by 30. And I'll multiply this by 30. So when I do that, I get 30x. Does this 30 and that 5 cancel? leaving me 6. What's 6 times 4? 24. And then this 30 and this 15 have common factors, and it'll leave me with 2. What's 2 times 16? 32. And this 30 and that 30 are going to cancel completely, leaving me just with 2, right? That's an equation I think everybody should be able to solve. We get down to 2x is equal to 22, so x is 11, right? Did anybody, when you see this 2 over 30 right there, did anybody reduce that to 15 right away? Okay, so I get 1 over 15. So the only thing that happens there, if you go about reducing that to 1 over 15, which I think is a good idea, so we get x over 4/5 plus or equal to 16 over 15x. You reduce it to 1 over 15. Now, what does that allow me? What's the common denominator? Now that you would probably multiply everything by 15. So if I do that, 15, 15, 15, 15, that 15 eliminates a factor of 2 out of this 30, right? So that basically tells me that my coefficients when I'm done should be half the size of these coefficients. So 15 times x gives me 15x. Those are going to cancel. They got a common factor of 5 in them, leaving me 3. So 3 times 4 is 12. That 15 and that 15 are going to cancel right away, give me 16x. 15 and 15 cancel, leaving me with 1. Is that 30? Double that. Is that 24? Double that 12. 32 is double 16, and 2 is double 1. So when that happens, when every single coefficient or constant is either amplified or divided by the same amount, then your result for x will still be the same. Okay, if you subtract 15x from both sides, subtract 1 from both sides, you get x to be 11. Okay, and that kind of plays into the idea. If you don't know what the common denominator is, okay, go ahead and multiply all your denominators together. So let's say we go back to that stage right there, okay? And I didn't know that 30 was a good choice, and I didn't know 15 was a good choice. If I take 5 times 15, I get 75. And then take 75 times 30, and it gives me 2,250 maybe, okay? Double check that real quick. 75 times 30, yeah, 2250. If I multiply everything by 2250, fractions go away. It just means my coefficients are much larger than they need to be. Does that make sense? But you can still solve the equation for x and still get down to 11. All right. So that's something to always think about as we're doing these types of problems. But there's so many different routes you can take to solve that. Okay. If we're going through something in class and I solve it one way, but you're a person that says I never do it that way, but I got this wrong. Can you do it the way I did it? Let me know, and I can try that way and see what we can come up with. All right. See if you can find out where you made your mistake. The thing I think about mathematics, especially high school